So solving, graphing, giving interval notation. Again, nothing new, just with the last lesson we saw most of this stuff at the very end. But now we can see that it's going to require some, a little bit more of what we've done already. But the good news, again, is that we treat these like they're equalities. It's not going to change. Nothing in the, about the inequality itself, symbol, is going to change until the very end, at least if we follow this method, okay? So I'm going to start with the 5x minus 2 is greater than or equal to 23. And first thing, no distribution here, no combining like terms, so I just don't want to isolate my x's. And that means I got to get rid of that minus 2 right there, so we'll have to add 2. Not just to one side, but to both sides right there. So that's going to zero that out just like I want. I'm going to drop my negative 5x. Does not change the inequality, but 23 plus 2 is 25. Then we'll divide both sides by the coefficient, negative 5. And here we go. This is, see this, the coefficient was negative 5, and that's the last step. It is the negative, which means that the inequality is going to need to flip on this one, okay? Maybe I'll color that a little bit different, but now I'm left with x. You can say phantom 1x if you'd like, but x is now less than or equal to what results is, looks like negative 5 here, okay? So right now, x is less than or equal to negative 5. Or, and this is where this other statement comes in, and we got to solve this one too. So with this one, there is distribution. So let's go ahead and, well, distribute 4 here. So that's 4 groups of 1x, which would be 4 x's. And then that's also 4 groups of negative 4, which would be negative 16. Nothing else there really changed. But now we're looking at the same type of equation that we just barely saw. I need to isolate my x's because there's no like terms to combine. And so that would be plus 16 on both sides. Zero those out, drop your 4x, which is now less than. Negative 8 plus 16 is positive 8. And then finally, we'll divide both sides by the coefficient 4. Now this coefficient is positive, so it will not flip the inequality. You just get x is less than 2. Okay? So 2 inequalities here. X is less than or equal to negative 5. And this is an important thing to do, at least when we have an exam on this kind of stuff. You got to put an or statement in between the two. Some students in the past have used the U for the or statement. That's fine. I don't mind writing the word or, which is weird because it's more writing, but I don't mind it, okay? But you're welcome to put a little U in between there to indicate that it's the union of these two, okay? Now, some of you noticed something odd about these two inequalities, which is good if you did. If you didn't, that's fine. The graph is going to reveal that what I've written right now for my inequality would have to get marked off points, and here's why, okay? So let's go ahead and graph these. So I got, there's 0, there's a 2 on the right because it's positive, negative 5 somewhere here on the left, just somewhere, okay? And I'll start with negative 5. So it says x is less than or equal to negative 5, so I got a closed circle there. Add negative 5, and it's not eating the x, so the line goes to the left. Okay, there's one of my graphs. The other inequality, x is less than 2, so that's an open circle of 2, but see this one also, this line also goes to the left, okay? Now based on what I'm seeing with the graph, I do not need both lines because it is an or statement, right? We can see everything to the left of pretty much and negative 5, and to the left of negative 5 here would make both of them true, but it only has to make one of them true because it's an or statement. So you could say, well, I'm going to go to negative 5 and then jump on the red one, and then I can go all the way to positive 2 here, and that's where it ends, right? So this interval would look more like it would go all the way to negative infinity, and then it would stop at 2, which is not included, okay? Now, because it does look like this, and we've seen this type of inequality happen before, that means that the actual inequality to write for this one would be that x is just less than 2. Okay, so that means that I really didn't need either of these. Well, I mean, I needed them to graph, but I only needed one of them in the end because of the or statement. Now you'll keep in mind, most of the time these actually go in different directions, and that's where we use the U in between the two intervals. But since these went in the same direction, we have to be careful with what we're looking at. An or statement only has to be one or the other. With the and statement, if this was an and statement, this would have ended at -5 instead of at 2. So I'll box in these so that we know where the answers are. There's one answer. We don't need the or statement. There's the interval, and then the graph. I'm not going to box it in because I suck at boxing. So yeah, it's a good question. So on a test, on an exam, like if I saw something like this, I'm okay with it because it still represents. You've shown that through the inequality and the interval that you understand what's going on, and so some students are okay to be like, yeah, I'm going to erase this stuff right here, and that makes it look real pretty. But just by the way that you write your inequality and your interval will help me to understand that you know that even though you've graphed this, I'm not saying I'm going to require you to erase that and make it look all super fancy. Like fanciness is great, classiness is awesome, but maybe I should be more picky. So